Assalamualaikum and good day everyone. My name is Muhammad Azizi bin Suko. I come from Polytechnic Banting Selangor. I'm thrilled to be here with you visually today exploring the research title Effect of Tungsten Polishing Angle on Arc Characteristic and Molten Pool Expansion in T-joint welding. I genuinely hope that by the end of this presentation, you'll have a clearer understanding of the subject and perhaps even share my enthusiasm for it. Let's begin. The study focused on the role of tungsten polishing angles in T-joint welding, a technique crucial in the industry like automotive and aerospace. The choice and preparation of tungsten electrodes central to TIG welding greatly influence welding quality. The problem statement. Welding parameters play a crucial role in determining the quality and performance of welded joint. In T-joint welding, the angle at which the tungsten electrode is polished can significantly impact arc characteristic and molten pool behavior. However, there is a lack of comprehensive understanding regarding the effect of tungsten polishing angle on this crucial welding aspect. From the problem statement, we found that there is a need to investigate and analyze the influence of tungsten polishing angle on arc characteristic and molten pool expansion in T-joint welding to optimize welding parameters and enhance weld quality. The research is set against a backdrop of understanding the dynamic of the welding process, with a focus on arc behavior, molten pool dynamics, and weld quality control. Within this scope, there's an interest in how different parameters, including the tungsten polishing angle, influence T-joint welding. The existing research provides valuable insight into related areas such as the behavior of the molten pool during welding process. Other studies have explored the effects of process parameters on arc coupling, weld pull, and keyhole behavior. Additionally, investigations have been conducted on the impact of rotating arc and non-asymmetric tungsten on molten pool flow pattern. Furthermore, research has been conducted on the surface tension of molten pools and its relation to activating fluxes. Gas flow rate has also been studied in helium arc welding, highlighting its effect on arc shape and molten pool behavior. These studies provide valuable insight into arc behavior, molten pool dynamic, and weld quality control. There is limited research on how tungsten polishing angle affect arc behavior and molten pool expansion in T-joint welding. Understanding this effect is crucial to optimize welding parameters and achieve desired welding quality. The study aims to explore the impact of 10-degree, 45-degree, and 90-degree polishing angles on this welding characteristic. The study examined how polishing angles affect arc stability, penetration, molten pool width, and heat distribution in T-joint welding. It aims to offer insight into the influence of these angles on welding performance and molten pool dynamic. This insight will aid in formulating guidelines for welders to enhance quality and outcomes in T-joint welding. For the methodology, I've adopted the straight line drawing technique for T-joint welding with a consistent torch movement and keep all experimental condition constant except for the tungsten angle for precise result. Examine three angles, 10, 45, and 90 degrees, representing common tungsten polishing angle, and use high amperage to highlight the angle-induced variation, and conducted repeated trials for each angle for consistency, and recorded detailed measurement on arc characteristic and molten pool expansion. For the research, for the methodology, we continue. Research design use a control experiment focusing on tungsten angle effect in straight line welding. Material and equipment use high quality T-joint carbon steel plates with a TIG welding system. And for the electrode preparation, selected a pure electrode and shaped them to specified angle with a grinding wheel. The parameter setup, Keep parameter like a current and gas flow rate constant, only varying tungsten angle. In welding, maintain consistent torch position and speed with the straight line drawing technique. Lastly, the data collection. Use cameras for arc and molten pool data. Measured weld dimension with the welding gauge. The result. There are several key findings. For the 10-degree polishing angle resulted in a large arc angle and significant molten pool expansion, lead to the formation of wider weld bead. Measurement, fillet weld actual throat thickness is 4 mm, fillet weld leg length is 6 mm, and weld face width is 7.70 mm. For the 45-degree polishing angle, it's produced a smaller arc angle than the 10 degrees angle, resulted in a moderately sized molten pool. Form narrower but taller weld bead. The fillet weld actual throat thickness is only 3 mm, fillet weld leg length is 5 mm, and weld face width is 7.0 mm. And for the 90-degree polishing angle, had the smallest arc and concentrated heat, lead to poor metal melting and narrowest weld bead. Measurement, fillet weld actual throat thickness only 3 mm, fillet weld leg length is 4 mm, and weld face width is 6.60 mm. So with this, we go to the discussion. For the 10-degree polishing angle, it's produced a larger arc angle and significant molten pool expansion, yielded wider weld bead, and depicted in figure 1 and figure 2. Contrary to modest expectation, this angle demonstrates benefit for application requiring wider weld. For the 45-degree polishing angle, created a moderately sized arc and molten pool as shown in figure 3 and 4. Metal accumulated more than its spread, resulting in narrower but taller weld bead. Suggested advantage for application that require thicker weld. And for the 90-degree polishing angle, produce the smallest arc with concentrated heat but ineffective heat distribution as illustrated in figure 5 and 6, resulted in narrower weld bead and challenges in optimal welding. Indicates potential drawback for T-joint welding with large tungsten polishing angle. The finding regarding the 10-degree angle confirmed prior studied by Sisik 2018 and Dobransky 2008, which suggests smaller tungsten polishing angles produce larger arc angle. The unexpected result, the 10-degree polishing angles efficiency was unexpectedly high despite initial modest expectation. The 90-degree angle, despite its concentrated arc, did not ensure efficient heat distribution across the joint. The ideal tungsten polishing angle varies with the welding task. While smaller angles favor wider welding, larger one benefit thicker weld. Excessively large angle risk poor heat distribution. This study deepens knowledge on tungsten angles in T-joint welding, guiding optimized processes. For the conclusion, the study examined how tungsten polishing angle, 10 degree, 45 and 90 degree, affect arc properties and molten pool expansion in T-joint welding. Smaller angles yield larger arcs and improve weld quality. In contrast, 90-degree angles limit arc size, potentially affecting heat distribution and welding result. Additionally, welding speed fluctuates across angles, indicating other factors influence penetrating depth. In T-joint welding, selecting the right tungsten polishing angle is key. Smaller angle favor wider weld, enhancing arc size, molten pool expansion, and weld quality. But overly small angle risks tungsten contamination and instability. On other hand, larger angles fit thicker weld, providing better process control and deeper penetration. However, angle as large as 90 degrees can be counterproductive. This finding of this research have practical implication for welders and welding engineers. Understanding the effect of tungsten polishing angle on arc characteristic, and molten pool expansion allows informed decision making in selecting the appropriate angle for T-joint welding application. Welding engineers can optimize welding parameters and develop guidelines for achieving high quality weld in T-joint configuration. In conclusion, this experimental investigation sheds light on the influence of tungsten polishing angle on arc characteristic and molten pool expansion in T-joint welding. The study provides valuable insight into the relationship between tungsten angle and welding performance. Future research can be built upon these findings by exploring additional welding techniques, position, and scenarios to further enhance our understanding of the broader application of different welding methods. That's all. Thank you for your attention. Thank you.